No, not everyone sounds bad. Bad singers sound bad. Good singers can sing without auto-tune. Maybe he is. All right, I don't know because Kingston does not do a lot of singing in my classroom. All right, how do we find the area of a rectangle? Length times width. Length times width, right? Length times width. Easy peasy lemon squeezy. How does a square differ? And how does a square remain the same as a rectangle?
You do the same thing, but both sides are the same length.
Both sides are the same. So in this square, because it is a rectangle, I could go LW, couldn't I?
Yeah.
Except L and W in a square, L equals W. Yeah, so do I need two different letters? No, I can use the same letter. We always use X, so I'm going to go ahead and continue to use a different letter, S, for side. So the area equals LW, but since L is W, the area equals S times S. Math guys are lazy. Do they write S times S? No, what do they write? S squared. Right? So, if you are given the area of a square, how can you determine the length of the side? Well, you guys are smart people. If the area equals S squared, then S must equal what? The square root of the area. That is where we get the term square root from. That's why we say square root. This symbol right here, you guys call it the square root sign. But that's not what it is. It is the radical sign. Because there are infinite roots. You do not necessarily find only square roots. Is everybody good? Excellent. So, this symbol is asking me to find the square root. Now, the square root means it is two equal factors. 2 times 2, 3 times 3, 4 times 4. 3.5 times 3.5. 6.4 times 6.4. Everybody good? As long as they're equal, you have a square root. Yeah? Okay. Now, let's apply that knowledge to a new situation. How do I find the volume of a rectangular prism? Well, we've still got a rectangle just like we had up top. So we've still got a W, we've still got an L. But what's added now? There's an H. And H is the direction of repetition, yes? We remember this from the first unit. So it's LWH. What's special about a cube? L equals W, which equals H. Which means I don't need LWH. What can I use instead? S, S, S. Which is, oh no, there's a snake. Or S cubed. See what I did there? Some of you might be, herpetophobic, which is, I think, fear of snakes. Because somebody who studies snakes is a herpetologist or herpologist. Not a herpes studier. A snake studier is a herpetologist. I think so. I seem to remember that from reading the third series of Unfortunate Events books, because Uncle Monty is a herpetologist, if I'm not mistaken. Alright, so if you know the volume of something, that equals S cubed. Now, you guys are smart. If S squared, we were looking for a square root, what must we be looking for with a 3? Right, a cubed root of volume equals S. So it's the same symbol, but now it's asking me to find how many? 3 equal factors. Now, let's apply this even further. What if there was a little 4? Now how many equal factors do I need? What if there was a 5? What if there was a 6? What if there was any number? Then that is the number of factors. Everybody got it? The small 3 is called the index number. And it tells us how many factors. Yeah? Yeah. Perfect square or perfect cube is any number with a square. Oh, wait, let's do this quicker. With a square root or a cube root that is rational. What do you mean by that, Mr. Myers? The first ones are easy. What's the square root of 4? 2. Is 2 a rational number? Yes. So is 4 a perfect square? Great. Square root of 4 equals 2. So it's a perfect square. What's the square root of 9?
3.
So is 9 a perfect square? Excellent. What's the cube root of 8? You do know. 2, because 2 times 2 times 2 is 8. So is 8 a perfect cube? Is 8 a perfect square? No. Everybody with me?
Whoa.
Everybody good? Okay, now let me ask you this. Is 2.25 a perfect square? Most of you will need to go to your calculator. Or you might recognize that that's 225, isn't it?
It is a perfect square.
It is, because it's 1.5. Is 1.5 rational? Yes. So even though it's a decimal, it can still be a perfect square. Does everybody understand? All right. Now, this sentence is one of those things in math where if you do it, you will be better. It's a good idea. Can I force you to? No. Would I ever test you on it? No. But it's a damn good idea to know these, which is why in your notes, I'm going to make you write them out. Start at 0. These are the squares. These are the roots. So, we'll start at 0. What's the square root of 0? 0. Let's go up by roots. If 1 is a root, what's its square? 1, because it's 1 times 1, right? If it's 2, what's its square? 4. If it's 3, what is it? 9. Carry on until you get a root of 400. I mean, a square of 400. Every number has a root, but not every number is a perfect square. Notice, please, the pattern is the roots are going up one at a time. The squares are going up. They're also going up by a pattern. So eventually you're going to not have these memorized, but you won't need to go to your calculator if you get the pattern. Go. 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100. I bet all of you are good to 10. And then it starts, some of you, most of you will be good to 12 because for some reason when we say learn your times tables, we randomly decided to stop at 12. So most everybody knows 121 and 11 and 144 and 12. And then it gets a little hazy. But now the pattern will kick in. 0, 1. How far from 1 to 4? 3. How far from 4 to 9? 5. How far from 9 to 16? 7. How far there? 9. 11. 13. 15. 17. 19. 21. 23. What's next? 25. So 169 is 13. 27. 196 is 14. 29. 225 is 15. 31. 256 is 16. 33, 289 is 17. 35, 324 is 18. 37, 361 is 19. And 39, 400 is 20. Which means you can now go on forever because you just keep adding the next odd number. Everybody cool? Numbers have patterns like that all through them. If you can learn them and remember a few of them, it becomes really helpful. Now I want to take your attention for a moment and look at this situation. What do you notice about that column and that column? It's the same thing with extra zeros, yes? Now I'm going to add in a third thing. What do you notice about that column? Okay. Now what do you notice about those two columns if I link them? And how does that relate to that one? This column says the square root of 400 equals 20, yes? This column says the square root of 4 equals 2, and the square root of 100 equals 10. Do any of you see a relationship here? What do you see, Eric? Multiply the square of 4 times 100. The square root of 4 times 100. What do you get? Square root of 400, right? What's the square? Isn't this the same as the square root of 4 times the square root of 100? See how it works? So if you can have a number here that you have the square root of, and you can break it down into smaller ones, it becomes a lot easier to deal with, yes? Everybody with me? Okay. Now you're going to do the same thing with cubes, but cubes are slightly more difficult. First one's easy. Second one, easy. What's 1 times 1 times 1? 1. What's 2 times 2 times 2? 8. We're good there. 3 times 3 times 3? 27. 4 times 4 times 4? 64. 5 times 5 times 5? 125. And now we're in trouble. We have trouble past that. So we'll help you out. I've got to erase all this black stuff here. Sorry, guys, I didn't leave enough. Oh, no. 216. You can do this with your calculator. 6 is 216. 7 is 343. 8 is 512. 9 is 729. And 10 is 1,000. Right? Now again, the same rules apply. What if I were to ask you to tell me the square root of 64,000? Could you do that without your calculator? You could, because that is the same as the square root of 64 times 1,000, correct? What's square root of 64? 4. What's square root of 1,000? Or cube root? 10. What's 4 times 10? 40. Done. Everyone see how it works? Everyone see how it works? And this is only perfect ones. I, of course, am going to teach you how to do this with not perfect ones. But if you see how to do it with perfect ones, you're really on the right tracks. Everybody cool with what we've written there in blue? Excellent. We're going to do one more thing, and then we're going to shut up, and you're not going to have any homework. Estimate. I know that you hate estimating. I know I tell you that you need to estimate. I know I tell you need to estimate because if you don't have an estimate and you do a half page of work and you have made a mistake, you're going to write it down. I'm going to have to mark it wrong. I know this will happen to you because I watched you guys do this. Let me give you a really simplified example. What is 7 plus 5? This is not a trick. 12. What if I asked you to do that on your calculator and your finger accidentally hit 7 plus 6? Then you hit equals. What would it be? 13. And if I wrote 7 plus 5 equals blank, and I said, do these with your calculator, and your calculator said 13 there, all of you would write down 13. Every single one of you would. And then I would say, what the hell are you doing? And you would say, oh, my calculator said so. Know how I know you would all do this? Because I just gave you a test on trig that I marked. And a great many of you told me numerous times that the hypotenuse was shorter than the other two sides. Why? Because the calculator said so. Right? So once again, this is the last time I'm going to do it, even though I've begged you to try and learn it. I'm going to show you another, again, how important it is to be able to estimate. Root of 72. Is that on our list of perfect squares? Look at it. No, it isn't, is it? What is on our list of perfect squares? 64, 8, 81, 9. Is root 72 in the middle there? So what does that make sense? The root of 72 is it must be between 8 and 9, correct? Now, how many steps are there between 64 and 81? 17, right? We're at 72, which is how many steps from 8? I just gave it away. How many steps from 64? 8! So I went 8 steps to get to 72 out of a total of how many? 17. So the square root of 72 must be 8 and 8/17, correct? Now let's estimate that. Isn't that awfully close? That means approximately to 8 and 8/16. And isn't that 8 and a half? Now let's check. Square root 72. 8.48. 8.5. Everybody see how to do it? Great. What's 180? What's it between? 169, which is 13, and 196, which is 14. How many steps am I past 169? 13 and 11 out of a possible 27. Yuck. But isn't that pretty close to 9 out of 27? Which is pretty close to 1/3, isn't it? 13 and 1/3, which would equal 13.33, right? Go to your calculator. Square root 180, 13.4. We said 13.333. Everybody see how it works? Try it with 300 on your own. Go. What's 300 between? I'm just waiting. We're going to stop there because we're going to run out of time. But we're going to do this one. I'd like to maybe try D and just ask you to do those last two on your own. But we'll see. If we didn't have the fire drill, we would have gotten exactly to where I wanted to get today. The end of this page with a little bit of discussion time and some work time on the assignment. It would have been perfect. It would have been like I planned it. Plans change. I wasn't planning to have 7 needles stuck into my leg and back today, but it happened. I got acupuncture today. That was part of my physiotherapy treatment. Only when it does what it's supposed to do. It doesn't hurt to get stuck in. What? Of course. So what's 300 between? 289, which is 17. 324, which is 18. It's how many steps from 289? 11. So it's 17 and 11 out of 35, right? Isn't that pretty close to 17 and 11 out of 33? Isn't it? Isn't 11 out of 33 1/3? So isn't that pretty close to 17.333? And what is it when you punch it into your calculator? That's okay.
17.32.
17.32. Wow. Everybody see? Now, obviously, some of you are going to say, but Mr. Myers, I would have just punched it into my calculator. I agree, you would have just punched into your calculator if this was the end of the question. But if this is the first step of 30, isn't it a good idea to say, well, it's going to be about 17? Then you can have an idea of where you're going. Picking up what I'm putting down? Now, what's different about D? Cube root. So, do I follow the same method? Can I? Should be a better question. Could I follow the same method? Sure I could. It's just going to be different numbers, right? 45 is close to what? 27, which is 3, and 64, which is 4. It's between them, yeah? Now, this is a bigger stretch, isn't it? Kind of hard to do in your head. So go ahead and estimate. Isn't this about 40? Isn't it? And isn't this about 20? So isn't it pretty darn close to 3 and 20 out of 40? Which would be 3.5, right? Let's check. No. Cube root, for me, cube root 45, 3.55. Use this time right now to make sure you can make your calculator do cube roots. You need to look for this button. Some of you will actually have a button with the 3. Some of you, it will be a second function, like inverse sine. And then there's 2 ways to do it. Forward calculator, you hit 3, you hit the cube root button, and then 45. Backwards calculator, you reverse 45, then you hit the cube root 3 button. But all you should be able to get your calculator say 3.55. Did everybody? Is everybody able to do it? If you have your calculator, push math. And then see how it's number 4? Number 4 has a cube root right there. We'll talk about how to find all the other roots tomorrow. Your job for tonight, try to do 2 questions. I'm giving you 23 hours to do 2 questions.